Alright, we've talked a lot about solving quadratic equations and how when we are looking for the zeros or the roots, what we're really looking for is where does the graph cross the x-axis. So it makes sense then that we can use a graph and work backwards from it to find those values where our parabola is intersecting with the x-axis. So quadratic equations will have 0, 1, or 2 real zeros or real roots. We know from the discriminant, if the discriminant is negative, it's not going to have any real roots, it would have 2 imaginary. If it's equal to 0, the discriminant 0, then we have 1 real 0. And if the discriminant is positive, then we have 2 real zeros. Okay, we talked about that last time. So if a graph has, or if a quadratic equation has no zeros, then the graph will not cross the x-axis. So your graph's either going to be floating completely above or floating completely below. And we say that the roots are imaginary. So you're going to have eyes in your answer. Okay, you can go ahead and match this with the graphs that's in your notes. Okay, this would be our discriminant is negative. If your quadratic equation has 1, 0, then your graph will touch the x-axis and bounce right back, either opening up or opening down. Okay, in which case your discriminant would have been equal to 0. We call this root right here, wherever it ends up being, we call that root a double root, okay, because it counts as an answer twice. Finally, if your quadratic equation has 2 real zeros, that means that it is crossing the x-axis 2 times. So twice because it's opening up, or maybe it's twice because it is opening down. Our discriminant here would have been a positive number. Alright, so we're going to use our calculators, make sure you have yours out next to you, to solve these all by graphing. In your notes packets, you have a list of how to do this, okay? Using your calculator, it has everything in there that we're going to do. I'm going to ask that you follow along with my calculator on the screen and your calculator. And then if you need to look back at those steps, they're all written out for you, so you don't have to rewatch the video if you forget. So first thing, enter your quadratic equation into the y equals feature of your calculator. So y equals 25x squared minus 20x plus 3. We don't have to worry about the equals 0 part. That's what we're going to be looking for on our graph. Right now we just want a picture of our overall parabola and what it looks like. Okay, so then go ahead and press graph. Okay, and then it says if you can see a good image of your parabola, skip to step 6. Well, I'm going to say we can see it, but it's not exactly the best image. So it says press zoom and try zoom 6. See if that helps. Does not help. I knew my calculator was already zoomed that way. So then try adjusting your window. So my window, I don't want to see as far left and right as I'm looking at right now because it's kind of hard for me to tell. And I know that low to high, I could probably get away with -5, maybe we'll just leave it at 15. Go ahead and press graph. Now I've got a little bit better picture of my parabola. I'm going to change the window one more time. And instead looking left to right, let's just go -2 to maybe 4. See what that does for us. The window game can be a guess and check thing. Okay? Just keep going until you can see your parabola pretty well. Then, go ahead and it says press second, then trace. So second, and then this trace button right here. We are looking for the zeros of our quadratic. This is potentially a 0 right here. So I want to move my spider somewhere to the left of where that point is. And press enter. And I'm going to swing my spider somewhere to the right and press enter. You'll notice these 2 little arrows pop up. That says that we're looking between these 2 x values to find this 0 right here. Then your calculator makes you guess, so move the spider closer to it, and there's your 0. So it says a 0 at 0.2, 0. So when we write our zeros, x is going to be equal to 0.2. Well, 0.2 is the same thing as 1/5. So x is equal to 1/5. You could also write it as 1/5, comma 0 as a point on your graph. So there's one of them. We're going to do the same thing. Second trace. Select the 0 feature. This time I'm looking for this 0 right here. So I want to move my spider just to the left of it. Press enter. Swing that spider over to the right. Press enter. Then it wants me to guess. And we're looking between these two x values right there. Okay, and the 0 actually occurs when x is equal to 0.6. Well, 0.6 is the same thing as 3/5, so you could write that as 3/5, comma 0. Okay, so those two solutions we could have also found by factoring. We would have ended up with factoring, we would have had a 5x minus 1 and a 5x minus 3 is equal to 0. Okay, this would factor this way, and then we would get our two answers. Alright, so remember all these things are related in what we're doing, just approaching it different ways. Alright, solve by graphing. First thing we need to do is get everything to one side, so we have a nice y equals. I'm going to go ahead and write this in standard form. Okay, go back to your calculator, go to your y equals, and go ahead and clear out what's written there. Start all over again. Go ahead and press graph. Can we see our parabola? No. So go ahead and try zoom 6. Can we see our parabola? Still not. I'm going to go ahead and change my window. This negative 42, we've got some pretty big numbers. So I'm going to look a little bit lower down on my y-axis. And let's say we're going to go negative 50. Maybe just negative 25. Okay, to 10, that should be okay. On the x scale, I'm going to look a little bit wider. Let's go negative 20 to 20. See what that gets us. Aha! There's my graph. Okay. My graph is a parabola that's opening downward. Is it ever going to cross the x-axis? Hopefully, like Dora the Explorer, you just answered and said no, in which case you cannot solve this one by graphing. There are no real solutions. Which means you could use the quadratic formula, but we are going to skip that. Alright, use your calculator to find the roots. Let's go y equals, clear it out, 2 x to the second plus 4x minus 5. Go ahead and graph it. Aha! My parabola is going to cross twice. I'm going to go ahead and press zoom 6. See if that gets a better picture for me. That looks like a great picture, in my opinion. So now again, I'm still following the steps that are in your packet. That's all I'm doing. Press second trace. We're going to select right here where it says 0, so you can press 2. Then it asks for a left bound, which means if I'm talking about this 0 right here, that's the one I'm going to focus on first. It tells me to move my spider somewhere to the left of that 0. So somewhere past it. That should be good. Press enter. Then I'm going to move somewhere to the right of that 0, so that would be about on it. So I need to go a little bit farther to the right. Press enter. So I'm looking in between these two x values right there. Can't really guess right on it, but we'll get close. We've got an x value of negative 2.870. Now, that one is not going to be able to be written as a nice rational number, so you can just leave your answer like that. You could also write it as a point if you want to. Okay? But we're just going to round to 3 decimal places. Unless your test or quiz says otherwise, go ahead and round to 3 just to make sure you carry enough decimals. Next one then, same thing, second trace. I'm looking for the zeros of this quadratic. This time I want to look over here at the 0, so I'm going to move my spider somewhere to the left, press enter. There's the 0, so I need to go a little bit to the right. Press enter. It's having me look between these 2 little bars right there. So I need to guess somewhere close. And it is at 0.871. The other one might have needed to be rounded too. I apologize for that. 0.871. So you could write your answer as 0.871, comma, 0. Okay? Let your calculator do the heavy lifting for you. If you don't remember those steps that we just went through, please have your packet out when you are doing this to practice. If your graph crosses twice, you need to find both zeros. If your graph touches once, you just find 1 0, and if it opens all above or all below, like our second example did, there are no real zeros to find. You would have to use the quadratic formula to find imaginary zeros.